Waiting on one.
Buenas tardes. Gracias por venir. Hoy va a ser la primera sesión de unos pre-workshops que vamos a estar teniendo, que nos llevan al hackathon del fin de semana. Este hackathon lo estamos haciendo en conjunto con la Universidad de Puerto Rico, con auspicio de Microsoft, IBM, ITDRC, Engine 4, una serie de otras entidades, como me acuerdo donde vamos a una serie de talleres temáticos sobre lo que es el manejo de desastres, tecnología, ese tipo de cosas, que es lo que se va a estar trabajando en el hackathon. Aquí mi compañero Javier va a ser es uno de los organizadores. Lo voy a dejar con ustedes para que se presente al presentador de hoy y podamos comenzar. Ahí, gracias por venir.
Thank you, José. Gracias, José. Aquí lo voy a hacer en español. Bueno, pues en corto, yo no soy el centro de atención hoy, así que mi nombre es Javier Mave. Soy trabajo para el Fideicomiso de Ciencia y Tecnología actualmente, y en conjunto con José y otros miembros, colegas de la comunidad, estamos organizando un hackathon que va a ocurrir el viernes a las 5 de la tarde. Empieza enfocado en el área de comunicaciones alternas y aplicaciones de manejo de data en momentos de emergencia. Como parte de ese hackathon, incluimos una serie de workshops que vamos a estar haciendo una semana. Este es el primero de ellos, y agradecemos mucho a Derek Coons, Chief of Operations de ITDRC, Information Technology and Disaster Research Center, que nos va a hablar hoy de tecnología satelital, mesh networks y otras cosas muy interesantes. Así que los dejo con Derek Coons. So I leave you with Derek Coons. So you're all yours. Thank you so much again.
All right, I didn't understand everything Javier said, and I'll apologize because I could try to do this in Spanish, but I would butcher it. So my apologies in advance on that. If I seem loud, please tell me, because I tend to talk loud anyway. As he said, right now I am the operations chief for ITDRC operations in Puerto Rico. We originally got here about a week after Maria. We're a nonprofit organization, and by that, I truly mean that, not like some nonprofits. I do not get paid a dime. None of our staff gets paid a dime. Even our director does not get paid a dime. We are truly a nonprofit. We work with a lot of different companies as our donors: Google, Dell, HP, Fortinet, has a lot to do with the operating in Puerto Rico. We're a 501c3. We were established in 2008. Hurricane Maria was one of the more unique operations that we participated in because this is the first time we've left the continental United States. We've done a lot of work in Texas and Florida, with the hurricanes down there, and in the Midwest and the California wildfires. We have operations running in southern Texas right now because they have a lot of flooding. But this was one of our more unique deployments. We actually do work with FEMA. Really, there's only a couple communication-related nonprofits that do that. That would be us and that Hope. I don't know if you're familiar with, you guys seen them around the island also. So that does enable us to provide a little bit more service because we can actually attach ourselves to FEMA and gather some of their resources, such as their fuel, things like that, and ability for us to stay. So we actually stayed on some of the FEMA ships when we first came down here. And also, our donors not only will give us equipment, but they will also sometimes allocate a staff. So we had engineers from Google and Dell actually on the ground down here helping too. We have about 1,000 credentialed members. Our search capacity is about 10,000, give or take. We have about 3,000 assets on hand. We actually have a warehouse in Texas for network gear, whether it be point-to-point, Wi-Fi gear, once multi-point, switches, routers, you name it, it's all stocked in our warehouse. 2017, we responded to 15 disasters, established 174 sites. If I can recall, about 60 of those were here in Puerto Rico. 41,136 volunteer hours for community served. We try to estimate how many actual people are affected, and that we help. We estimated above 10 million. On average, we can respond to an incident in 24 hours. Obviously, Puerto Rico was a little bit different. We had to put a bunch of people on planes, try to get them down here, and getting into SJU was difficult at first. On the average deployment length is going to be about 5 weeks. The longest operation that's been done was Joplin Tornado. There's still assets actually there. And in a lot of cases, we will leave our assets, with the organizations that we help. There's places in Puerto Rico that they said, well, when are we going to kind of get the switches? I said, no, it's not going to happen. You can keep them. And obviously, this is the largest operation. I have to advance these manually because we're doing this. This is a map of pretty much every site, minus a few that we actually had in Puerto Rico. Some of them are still active, actually. As you can see, we focused a lot on the medical side here when it comes to hospitals, the CBTs, OMME, rescue teams, EMS dispatch. We worked with a lot of organizations like that. Emergency management, public safety, and government. We also have public access points too. As an organization, we pretty much triage, the sites we're under service. First and foremost, it's going to be life safety. So, your rescue squads, OMME, and hospitals that are taking out a lot of people. We're going to service them first. Once things start to get a little bit stabilized, then we'll do traditional mass care. Most of your hospitals, we do a lot of work with the hospital network solution around the time. They have hospitals in Monrovies or Colby's and a few other areas. And after that, then we focus on community recovery. That's when we're doing more, with the public access points, things like libraries. We kind of differ from that a little bit there on this. We started doing community recovery a little bit early because, as you all know, when it came to the FEMA assistance forms, they wanted you to do them online. It's kind of hard to do that without internet, to do them online. So then they came up with a plan. They had to actually pay for forms, and they would give them out to OMB to go out and try to collect, all the data on paper. Then they go back to the FEMA zone command center, and then they would take that, and then they go to the JFO in San Juan. The problem with that is papers get lost, and it's changing hands multiple times. The other problem with that is people have really bad handwriting. I know, my handwriting sucks. And sometimes that information will get, to FEMA. They can't read it. Next thing you know, you're applying, you don't have it. You never get it. You cannot actually get processed. So it was important for us to actually get some of that community access out there. And we worked with Dell, and they graciously donated a lot of Chromebooks. So we had in multiple communities, here's where they could actually go and do the FEMA claim. Emergency services, so we worked a lot with the both the state and municipal police, 911 dispatch centers, critical infrastructure. I'll let you all guess what this is. It looks like a very large engine, because that's precisely what it is. Who's familiar with the situation in Vieques? So their power was originally serviced by an undersea cable coming from Lookout, if I remember correctly. That cable's not doing so hot. It's not functioning at all. So they had to produce all their power on Vieques. So they have what's called the mega generator. This is the mega generator. 18 cylinders, each cylinder is about this big. It consumes about 4,000 gallons of diesel a day. That's what's powering Vieques right now. Javier seemed surprised, he didn't know that. I thought I told you about that. But the problem with that too is you have
I was surprised about the amount of diesel that, I didn't know the amount of diesel that it was consuming.
Oh, it consumes a lot. I don't have pictures of the tanks, but I do have it that are on the slides. The problem with that also is they have to get that diesel over there. And if anybody's ever taken a ferry to Vieques, you can imagine how fun that is. It's not. So the problem here, it's in a remote part of Vieques. So they have to report their fuel level to get more fuel brought to them, maintenance issues. They have a SCADA attached to that, where it can actually be remotely monitored, but that wasn't possible because they had no connection. So that was actually one of our sites that we worked with, because they were literally driving to the port 8 times a day to report all their stats and statistics. And that was taking a lot of time from them doing maintenance and actually keeping the generators running. It services a decent amount of the island, about 60 to 65%. So, and that was a problem. The other thing is, with that much diesel sitting there, they have to have a way to communicate if something's going wrong. By something going wrong is, if you have that much diesel, someone might want to rob you. And it might be good to make a phone call if somebody's robbing you to stop that. They did have a normal sat phone. Problem with the normal sat phone is, you have to go outside, you have to wait. We actually use VSAT and an analog telephone adapter where they set a normal desk phone inside, and the actual external antenna was always connected so they can actually receive calls and make calls. We work with the mobile trauma center, so this was a mobile trauma center that actually had set up over in Vieques after their CDT was shuttered. Their CDT took a lot of physical damage. And they ended up in tents, actually, in the parking lot. And they were supposed to move, but I'm not sure if that's actually happened yet. So a lot of the medical treatment over there is in mobile units. And connecting responders. So that's also important. You have a lot of nonprofits who come down here, and they want to help, but they require connectivity too. They have to get supplies down here, they have to be able to relay information. So we work with them also. Speaking of, when I was talking about the medical facilities in Vieques, those are the tents that I'm talking about. That's what the CDT operates on, last night checked. The facility on the right is where they're supposed to move, but I don't know if that's the 30 minutes. And you can notice here, this is a solar field actually set up by Tesla. Tesla came down there and set that up to support them on power. government facilities. A lot of the times the government has the ability to connect themselves, but in some cases they don't. So we'll also help them. And of course, providers. Kaye, that's a prime example of where we set up, because there was a very large disaster resource center. We used 2 VSATs there to help people get their FEMA claim forms processed. We had a lot of laptops down there for them to do that. So, and the same thing, there, that was in Toa Alta on the left. All right, so what happens? Disaster starts. What are you going to do? There's going to be infrastructure impact. Power poles are going to be down. Fiber optic lines can get severed, and obviously anything on a tower can get damaged, whether it be one of the cellular radios or any point-to-point, which I noticed there's a lot of here in Puerto Rico. Phone lines, copper phone lines, they were a mess, what I dealt with. And how quick and if Claro was going to repair all those, I'm not too sure. I mean, how many people really use copper for their phone lines these days? It's not super common, so I really don't know how much they're going to focus on that. Cable and data circuits. Your cell towers and microwave links. That was one of the major impacts that you had here. Your LMAO systems for your 911, your ambulances. A lot of places have issues with those. The power grid and power generation. Transportation, water and sewer, petroleum and fuel. All that ties in, because especially for us, if we're trying to get somewhere and the roads are shot, we can get there. One place that didn't matter was Utuado. We went in with a helicopter and was actually able to establish contacts there. And obviously homes and community facilities. And your commodities and supply chain, that's a huge thing. We can get all the people on the ground, but if we can't get the goods here to help, it's not going to matter. So your pre-existing wireless and alternate power sources, they're probably going to get damaged. This is a VSAT unit that was in Catondo, and that was part of their point network that they had. The turbines you see there are in the Guapo. None of them are operating now. They're destroyed. Third picture, that's also in Catondo. The fourth picture, that is a tower on top of the Mennonite Hospital in Alameda. They lost pretty much all their comms out that was radio based. The one good thing I will say about the hospital there is they fired up their generators as Maria was approaching, and then threw the transfer switch to go off grid when it got close. They actually did not have any hiccups in patient care on Kendall Valley during Maria. All right, now as of our kid meets, you all probably, if anybody's taking psychology, you've seen this. It's a little bit different, to us when it comes to communications. Battery life and Wi-Fi. Those are your basics. So what are you going to do? Now, when Maria hit, the island technically did not lose connectivity. The island itself did. Your fibers going into the point of presence in SIM 1 were intact. For the most part, T-Mobile took a hit. But for the most part, connectivity was not lost to the island. And that's kind of a bad thing, though, to maybe in the future is you have a simple point of failure there. What happens if they do get wiped out, if there's an accident? It's going to change everything. Because right now, the problem is distributing across the island. If that gets severed, depending on how bad it is, the way you're going to recover is going to be different. What we like and what currently exists is two different things. There's a lot of technology, and that's one of the purposes here is to find, a nice, resilient method of communication. there's a lot of gear out there that we would like, but it just don't exist. Or it may be possible to do it. It technically exists, but what you can lawfully use is different than what you can actually build. Trust me, the FCC still exists. I know. Even during disasters, they don't care. They have laws and they do enforce them. And it's not saying if there is the next time, will the fighters that surfacing the island survive? If they don't, that's going to change how we react completely. They did in Reagan. You may not be able to physically access the areas you need to help in. We incurred that a lot. And that's right. That's the helicopter that got us into the market. So when we're looking at this from our standpoint, and something that you're all going to be looking at also, is what kind of data do you need to move? How does it need to be moved? Because it's going to differ. It's going to vary from entity to entity. Geospatial data and diagnostic medical imagery takes a lot of bandwidth. Some data, while light, will have a large impact. Text-based reports, form submission. That's what I was talking about earlier. Remember the FEMA claims. That doesn't take a lot of bandwidth. It doesn't necessarily, you don't have to have a gigasecond, for that. You can do a lot with a little. Public access for survivors to reconnect. WhatsApp, as long as you're not, video or, voice. That doesn't take a lot. But it has to be closely managed for preventive use because it will happen. It doesn't matter where it is. It doesn't matter if it is in Texas, Florida, or here in Puerto Rico. Network connections get abused during disasters. It happens. And it doesn't matter if it's in a government office. It doesn't matter if it's in a church. It doesn't matter if it's at a DRC. It doesn't matter. It will get abused unless it's actually managed actively. We want to promote good morale and communication, but we got to live within our means on bandwidth. So that's one of the things. Well, how do you enable people to send messages to their family, over Facebook Messenger, but prevent them, from using a video call or video chat? And luckily, the firewalls that we use supported deep packet inspection, and we could actually stop the video calls that allow the actual text-based communication using Facebook Messenger to continue through. Intra-island or extra-island. So if you're going to be building a mesh network or any sort of network, what is your goal? To get information from one side down to the other, or do you need actual internet? With some of the mesh networks that's been thought about, they really don't have a gateway to the internet. So you might be able to get information around in the community, but if you need to get that information to an entity on the island, it's not going to happen. Like I said, we can have the best mesh network there is, but there's still going to be a need to get a lot of data off the island. So one of the primary technologies we use is VSAT. Hughes is one of our donors. They were going to be giving service to Puerto Rico as a service area prior to Maria. That was in the plans. It wasn't already done. Maria sped that up. So they actually were able to actually put some beams where they had a footprint over Puerto Rico. VSAT, it stands for Very Small Aperture Terminal, which I think is kind of funny because there's nothing necessarily very small about that. They can be up to, I think, 2 meters before they're considered no longer very small. But they require clear line of sight. That is the one thing about them. So if you're in an area, an urban area with a lot of tall buildings, you're going to have to go to the top of the building, more than likely, to mount that. Or if you're in a very rural area, we incurred this in Medicare. There's this one community that's in a really sunk-in valley, and there was really no good place to mount the VSAT except close to a hillside. And the beam would not be able to actually go to the sky. It was actually flipping the hillside and it was causing problems. So we had to find another location to mount that. The speeds vary with VSAT, 2 to 25 meg down on average, depending on who your provider is. Like I said, we use Hughes, so we can only get about 25 down. If Your uplink always sucks with a VSAT. That's just how it is. You're going to get 1 to 3 up. That's not going to change. Not right now. Until they can start getting some satellites that orbit a little bit closer, and that's what a lot of people are trying to do, that may change. Your satellites, VSATs now typically operate your pay band, which is 18.3 to 31 gigahertz. So it is very, very high frequency. Problem with that is anything that gets in between that beam and the satellite can cause some problems. Usually has a data cap, no matter who the provider is. With Hughes, it's a soft data cap. So if you see, the actual a lot of data that they give you, they'll throttle you down from anywhere from 1 to 3 megasecond. But aside from that, they don't do anything. Now, when we're using it for disaster response, the way the accounts are set up, yeah, they'll hit the data cap, but then I just have to call them and say reset it, and it'll automatically reset it. But a lot of businesses ask about that because obviously a lot of people think about business continuity for next time. So I've been explaining this many, many times. Currently, you're going to have high latency. That's what I was talking about with the lower orbiting satellites. You're going to incur 500 milliseconds of latency, usually at the minimum when using VSAT. Here we use EchoStar 19. That's the satellite I was talking about that was going to be used for here, but they sped up. It's actually used for here. The estimator is roughly southwest, 255 degrees magnetic. So, not that that necessarily matters, but now you know. It's 22,236 miles above the planet. So now you understand where that latency is coming from. We're literally going to be taking the data, sending it 22,000 miles into the sky. It's going to be taken and then sent back down to Hughes network operation centers. So normally, you get 250 milliseconds up, 250 milliseconds down. It draws more electrical current than you would suspect. And the reason I mention that is when we're working in really remote areas that doesn't have a very strong grid. Some people want us to set them up on really small, like solar units. Like, have you ever seen any of the ones from
Goal Zero?
Goal Zero, yeah. Yeah, so you would think like that the biggest, battery bank would support this. Not necessarily, because the actual receive function powering the trio, that's at the end of the actual horn on the end of the satellite, doesn't take much, but transmitting takes a lot of power. So it normally at one end it normally draws about 2 amps, 220 watts. So that's roughly equivalent to running a 55-inch TV or a medium-sized blender 24/7. So take that into consideration when you're designing on something. You want to design a power bank or an alternative power solution to power a VSAT. It takes more than even that to do. There's unique challenges with voice over IP. That has to do with the latency. The analog telephone adapters that we use, that was provided by Hughes, they were already pre-configured. They work great. Now, if you start using, other like a Cisco or some of the OB, I don't know if you've seen some of the OB analog telephone adapters. You have to go in, and a lot of it's trial and error. Again, get set up. You have to contact the voice over IP provider. Sometimes they have specific proxies set up for people that's using VSAT to take care of issues with the latency. A lot of times we get an inbound call, but we can't make a call out. One of the specific problems that we had is you would have to force it to use TLS for encryption, and you'd have to turn on hard ports, which is one of the signaling methods that uses to cause delays. You'd have to use an alternative method. Point to point. You've seen these all over the island, and obviously we were going to use those to get sites back up in addition to our VSAT. In some cases, we'd have VSAT be our main backhaul, and we would distribute it to multiple areas using point to point and multi-point. This is actually just ubiquity here with a really nice antenna on it. It's nothing too fancy. And point to multi, which is No different except you have a sector antenna and it can service multiple clients instead of one individual. So on that, you have many vendors and many frequencies that can be used. 900 megahertz, you'll notice I have an asterisk on that, I'll get to that in a minute. 2.4 gigahertz, 5 gigahertz, and what some people don't realize is there is a 24 gigahertz and 60 gigahertz unlicensed band that can be used. It doesn't go very far, so you're only going to really use that in very, very close proximity for something that requires a lot of bandwidth. Not all frequencies are created equal. Nearly all these are line of sight, except 900 megahertz has a little bit of flexibility. You can get near line of sight and still get some connectivity with 900 megahertz. One of the problems with 900 megahertz is there's not a ton of vendors that use it. Ubiquity does use 900 megahertz in some of their gear. Cambium also does. Do not believe Verizon does. The problem with 900 megahertz is, I'm probably showing my age. Remember 900 megahertz cordless phones? A lot of things. Yeah. There's a lot of stuff that operates at 900 megahertz, so it's a crowded band, and the actual portion that is unlicensed is pretty small. So you'll have to do a spectrum study before you avoid anything like that, because 900 megahertz can be pretty noisy. But then again, in mountain areas like Orocopes and Utuado, there might not be a lot of stuff in the air, and you might want to use that. Because it can penetrate, go around trees. I don't want to say penetrate, because it really doesn't penetrate, it bends around. We never did deploy any of the 900 megahertz gear down here. I've used it back in the States for a lot of different applications, but we're keeping that close at hand in case anything does happen. So the main factor when you're deploying this kind of gear is going to be your terrain and elevation. I know I didn't realize it until I got down here. Y'all got mountains. I mean, I knew there was mountains, but I didn't know there was mountains like that. I mean, as soon as you get off the coast, as far as I'm concerned, you're in the mountains almost. And not a lot of people realize that. I mean, obviously you all do, you all live here. But that causes a lot of unique challenges when you're using, point to point here, because it's line of sight. And it caused a lot of problems for multiple responders down there. Frequency availability and saturation. So where there's so much that's being used, you may not be able to find a clear area in the spectrum to actually even get the throughput that you want. Especially 2.4 gigahertz. I'll get into that, even in smaller areas, not even in point-to-point applications. The antenna is used, obviously. You can use an omnidirectional antenna, or you can use an actual directional antenna, such as the AV antenna or a panel antenna. Obviously, an omnidirectional antenna, you can get all around it, but it's not going to be nearly as strong. But in some applications, that's what's going to be best. Points where the antenna can be mounted. That's what I was talking about. If you're dealing in a built-up urban area, you're pretty much going to have to get to the roof. And that was a problem that we had in some cases. We'd be working in a hospital, and right after it was a much different flavor. You might be talking with the hospital administrator and the maintenance guy who has the keys to get on the roof. Oh, well, we hadn't seen him. We hadn't seen him since the hurricane. Out come the bolt cutters. But that's going to be a major concern. Where can you mount that antenna? Because if you mount it in that location, you can have the best gear. It's not going to happen. This is the San Juan Joint Field Office. So this is where, has anyone been to the JFO when it was there in the convention center? You were there? Okay. It was a mess, spectrum-wise. So if you had an access point there, and it was broadcasting on 2.4 gigahertz only, do you think it could be used? It couldn't. It actually would not work at all. You could connect, but you would have half a loss. It would be virtually unusable. So you would always tell whether to 5 gigahertz. The problem with that is some machines automatically connect to 2.4, and you have to tell them specifically connect to 5 gigahertz, or you have to create a separate SIP But this one I'm talking about with frequency saturation. And you're going to get that in point-to-point applications too. Talking about the mounting. Mounted high and mounted solid. This was a thorn in my side. So this is also in a Alta, which you saw the picture before, and it had RPSAT, the one that's actually mounted properly up there. That's high. So some other organizations came by that were contracted by FEMA and installed 2 more, which you can see down there on the sleds with the concrete. The sleds with the concrete is fine in a mobile area where you're not moving them from site to site. So the problem with that is somebody can knock those around, and we're beaming that signal 22,000 miles. It doesn't take a lot of movement to screw that up. So if you're using VSAT or point-to-point, try to stay away from any mounts like that. And the other problem is that even if they did bolt that directly into the ground, the only thing that we use to screw that up is a large box truck beside the part there. And that'll go all the connectivity. The other technology that we used down here a little bit later was LTE and mobile handsets. Now there's some issues with that. It has the capability to provide relatively high data transfer and low latency. Now you notice this is the capability. And you normally have a seamless transition when you're going from one tower to the next and get handed off. It's FCC regulated, so you're not going to have to worry about interference or the actual spectrum getting saturated. And it's extremely easy, usually, for the end user to use. Now, if you're using it to connect an enterprise LAN, it's going to require more skilled technician or particular equipment to use it as a primary backhaul. So, because if you have like a little hotspot, I'm sorry, that's not going to serve as a hotspot. Most of the time, even if you have 10 people around out with a laptop, it's not going to even be able to handle that. But they have specific LTE modems that can be used to feed a router, and those work good. If not, there's other methods. Some of the hotspots can actually be used as a USB modem, and some switches and routers do support actually using that as a failover. Your actual mobile and smart handsets have an additional advantage being able to use the other radios on board, specifically Wi-Fi. I'll get into that a little bit later on why that matters. Wi-Fi, Bluetooth, and near-field communication. Okay, so I know a lot of people probably ran into this issue when they were down here. I had no signal, now I have 4 bars, and it still sucks. I'm pretty sure that happened to almost everyone down here. It happened to me a lot. Since a lot of us don't work directly with the actual cell carriers, some of the problems that we incur when using them is frustrating and don't make sense. And it's actually a lot more simple than you would think on what's causing these issues. In a broad sense, think of the LTE network as just a large enterprise wireless LAN. Now, the problem is that the towers were physically damaged and destroyed. That makes sense. We all understand that. The radios attached to the tower were damaged or destroyed. We understand that. Power was disrupted. We understand that. This is the killer. The tower's radio backhaul. The tower and radio backhaul was disrupted, or it's using a failover such as VSAT or microwave, or it's saturated. So a good example of that is if you go to a really crowded event, like at a big concert or something, and you probably experienced this before, and you'll try to use your phone, 4 bars LTE, but it's not performing. I mean, you're not able to really transmit any data or receive any data. Take your phone, if your phone will allow you to do it, I know with Sprint you can, and change your mobile network mode to say CDMA instead of LTE, which is 3G. So your phone will redo, and your 3G connection will actually be faster than the cracked 4G connection you had because it's not saturated. You have everybody with their new phones using 4G, and that radio is just getting bombarded, and it can't do it. You experience that down here too. But there might be one area where the cell phones were working, the actual cell tower was working, and you normally saw them because everybody was pulled over on the side of the road right there talking. Well, that was going to overload that one specific radio. So that was the problem that a lot of people were running. But the backhaul, that's the major issue. It's going from your phone to the tower and then to where? It has to go somewhere. So a lot of the towers, you know, they had fiber optic lines going to them that were just storage. They had some other medium ones that was just storage. So then, or they were being fed primarily by a microwave connection, and that could have been misaligned, that didn't survive at all. Or they were using VSAT. I know for a fact many cell carriers were using VSAT as a failover because the actual terrestrial lines are damaged to it. And remember what I said about the VSAT? You're normally going to get between 2 and 25 megaseconds. So you can imagine a bunch of people trying to use a cell tower that was originally being, you know, had a fiber as a backhaul, and now it's using a VSAT. You're getting a strong connection to the actual 4G rate, but after it leaves there, you have a bottleneck. So that's what I'm saying. Think of it as a wireless, enterprise wireless LAN. You might be able to connect to the access point, but there could be a cable fault between that access point and the router. There could be so many other issues that happen after that access point. That's why you were getting 4 bars, and things wasn't necessarily going the way you thought they would. It's extremely simple, but a lot of very well-educated people, I know, once I told them that, they was like, oh wow. But it's just not something that we traditionally think of. But that was a common problem, and still is, especially for me. I live on the outskirts of Coglis. On a good day, I get 3 megasecond. But it's the Achilles tendon, tower's backhaul. If the tower doesn't have a good backhaul, it's not going to happen. Mesh networking, this is what this is all about, right? This is just a generic diagram of the mesh network. Mesh networks are still being perfected for wide area use. Mesh networks in a smaller area, yes, we've got that figured out. But if you wanted to have a true mesh network over the entire island of Puerto Rico, right now it's not feasible. The technology is not there. It's proven it's resilient, self-healing, and it's useful in smaller scale deployments. Now, when I'm talking about this, I'm talking about a pure mesh network, not one that's split up into multiple mesh networks with a gateway. But literally, each node talks to another node that never talks to another, like a backhaul, or you can communicate with one. Say you had one over in MyBus, you had a mesh network over there, you had a mesh network over here on the East Coast, here the same one. And there was no nodes in between them to actually relay that, and it went over VSAT event. That's not a true mesh network. A true mesh network isn't going to need anything else to communicate other than the nodes themselves. And right now, there's not enough powerful radios really to do that without having them really close together, essentially forming a line across the island. We do deploy mesh networks though, and they're capable of servicing small communities. Smaller mesh networks can be linked to a point-to-point or a point-to-multipoint or a VSAT, and they'll be connected to a centralized backhaul. So for instance, we may stand up a sector antenna for a point-to-multipoint at a very high part of the mountain or a tower, depending on what's available to us. And we may have 3 clients that can connect to that, and they'll be spread out. And then from there, we can have a small mesh network coming off of those, and it can serve as like a small community. 3 of them. But one community is not talking directly to another community with the mesh network. It's going this point to point and into a router. And they can also be autonomous with their own backhaul. They don't necessarily have to, like I said, go all to the point to point system. They all have their own VSAT. Multiple vendors produce hardware for this. Ruckus is a company we work with a lot. Ubiquity, Cisco, Canyon, they're all capable of setting up mesh networks, but they're just not to where you can do it over a very long range. You have to have multiple nodes in a small area to do it. And that's the largest hurdle for very large area mesh networks. They're regulatory. You can't put an extremely powerful radio on certain frequencies because it's going to walk on other frequencies. And the FCC has limits, for that. And there's certain frequencies that you can't use. Some of the mesh products that were being explored to be used down here. One of them has a line, I guess you could say, that operates on 900 megahertz, and then they have their Pro series, and that operates in an actual license frequency. I believe 450 megahertz, which is a public statement that you have to be licensed to use that. And even then, you're still going to be regulated on your maximum output power. So, as of right now, that's one of the hurdles that you're going to have, and it's going to be difficult to do that without disrupting other services and potentially getting yourself in legal trouble. So, bandwidth management. This is a issue with everything when it comes to emergency communications. This is an actual ticket that I got here. They wanted access to Pornhub. That's why I'm going, the most important part of any network is going to be bandwidth management during a time of crisis. You would think that people would keep their senses about them and limit things. No, that don't happen. That doesn't happen. And they went as far to think that I had religious motivation for blocking Pornhub. I don't. I'll block Dora the Explorer too. Anything that's going to saturate, our connection, we're not going to. We can't have that. But again, the section on traffic. Once we get it up, this is the most important issue. A lot of organizations, both ones that's recognized that work with FEMA and the Sun Network Autonomous down here, they would get backhauls put all over the island. They were moving fast, but the problem was they were getting them in place and they weren't managing them. And they were essentially useless. But the traffic management is not only for irreverent people like I got that ticket from, but it's also for automated processes that happen in the background, like certain updates. I'm sorry, if you're not updating iOS, it's not happening. Or even, I'm all about patching, patch management, I'm with that, but we said no Windows updates. It's not happening right now. Not as of right now. And some of the times we would be working with a facility and like, where's your sysadmin? We hadn't seen them since the hurricane. Okay, because normally, you can turn off the updates with GPO, or if you have a WSUS server, whatever. A lot of times, those staff weren't there, they were busy doing other things, so we would manage that for them. Like, they could be rendered completely useless without it. I've seen it happen. BitTorrent, YouTube, Netflix. You would think people had other things to do, but it's universal. I mean, we didn't just experience it here. We've seen it everywhere. Florida, Texas, California. People will use it for whatever they want to. And it's really all experience for the user and ensures that people benefit from the installation. The other thing is when you're dealing with donated services also, the donors prefer you to manage and make sure that their services that are donated are being used appropriately. They don't mind to re-up, a data cap or something like that, but if they look at the traffic line, this is what we're re-upping it for, they may not be as apt to donate more services. So us as an organization have to be good custodians of that service. It also allows the detection of misappropriation and theft of equipment and or services. Not that that would ever happen. That would never happen. A good example of this is if you actively manage, the traffic, and you see very, very little traffic. That can be alarming, especially if it's at a site that's supposed to. Let me see how I can say this without identifying any specific facilities. A facility that would expect to see a lot of bandwidth being used, and you don't, and then you check the VHCP leases, and you only see 2 devices, and they may belong to somebody in a position of power. That's misappropriation. So that's another reason that it's very important to always monitor any sort of network, whether it be a mesh network, point to point. Because again, maybe they're wanting to watch Netflix, one of them saturated that way, or maybe they were wanting it for themselves. And I have no idea why they would do that. Sometimes there's more than enough to go around, but it has been observed, it has happened. It's happened in other areas, it's happened here. I know for a fact it's happened here, because I confronted the entity that was doing it. But it's a fact of life. Disasters are going to bring out the best in people, and it's also going to bring out the worst in people. A lot of people band together, try to help their neighbors, fly down from the middle of Kentucky and essentially move here. That's what I did. But then there's some people who are going to look at this as a way to take advantage of people, and to line their own pockets, or just to help themselves. So you always have to be checking the integrity of people that use your services. It should be active and it should be regularly assessed. So I can set up a really nice firewall policy, and that might be fine and dandy. They'll check on that. There'll be something. You have to always go find something else. You have to check it every day. Even when I was back home in Kentucky, at my home office, I had a pretty large setup with 6 monitors. 3 of them was pretty much set up as a knock for Puerto Rico when I was home for Thanksgiving. Actually monitoring traffic and having to tweak and change some of the firewall policies. All right, but keeping it real. Plan for the worst, hope for the best. Everything that you may come up with may or may not work. And that's why you want to plan for the worst case scenario. Don't assume anything. Remain optimistic. You don't want to be gloom and doom all the time. That's kind of my job, to assume it's always going to be bad. But stay realistic at the same time. You don't want to be so fearful that, oh, nothing will ever work. Because there's always a way to get it to work, but stay realistic. And you can make a difference. No matter your skill level, whether you're more on the development side, you're more on the hardware side, networking side, you don't even necessarily have to have a technical skill set to make a difference. Because everybody has a plan until they get punched in the mouth. All your contingency plans will go out the window. Everything that you thought would work will probably fail. So be ready to think on the fly, because plans change. And I can see the future. You're going to get punched in the mouth. Whether or not it's because of a hurricane or whatever, just something in your normal day job. You're going to get hit with something out of left field. And you're not necessarily going to have a plan for it. The thing is being able to think on your feet and be resilient and overcome that. It may look stupid, but you'll be getting things done. That's me sitting on top of an SUV on a sat phone with a cable going to the light adapter. Because my sat phone ran out of power. And where I was located on the ground, I could not get a signal. So actually I could climb on top of the vehicle and do that to get a VSAT activated, because for some reason it wasn't doing its own self-activation, so I actually had to call Hughes. And there was no cell service or anything. But just be flexible. And if it looks stupid and it works, it's not stupid. It's all right. But it's not about us. Remember that. It's never about you. That's what I'm saying. If it looks stupid, who cares? Because you're not caring about how you look. It's about helping the community. These are people that we encountered during our times down there. That's who we need to be thinking about. We don't have to, when we design these systems and work on these projects, it's okay to take credit for it. It's okay to be proud of your work. That's fine. I never make it about me. And a matter of fact, most people don't even know my full name, and I prefer them not to. Because I'm not trying to make a name for myself. I'm not trying to set up a business down here. That's not what I'm about. So always the focus should be on the community. That's what we ask ourselves whenever we're setting up any sort of background is, how does this help the community? Even if we're helping a government entity, how does that trickle down to the community? That's always what you need to be thinking about. How does it ultimately help the community? You may be able to get connectivity to this place, whatever, but if that does not help the people, ultimately, what good is it? Of course, I have to mention the people that helped us when we were down here. I'm not going to name them all. I mentioned some of them already. But all of these companies have been a great help and have donated services, personnel, and money to help with the recovery here in Florida. And not just tech companies, there's a lot of other companies too. Southwest Airlines flew all of our staff here. I mean, they gave us vouchers, and they also supplied the cargo services. That's when somebody at the logistics train getting interrupted. That's a major thing. I mean, especially with the equipment we're dealing with, it's heavy. So we have to have it shipped. Gold Zero helped us out also. But get involved, keep doing the work you guys are doing. And that's great. In an emergency, we may be able to provide backhauls for some of the mesh networks you all develop. That's going back to what I was talking about. The pure mesh network right now is not exactly feasible. But having multiple mesh networks connected to a gateway and they can talk to each other is about the next best thing. And you saw the map previously of all the sites we have across the island. You know, we can get to the last mile. You can get everything there. We can get you to a gateway and get it distributed to the rest of the island and the rest of the world. So we're going to be keeping an eye on some of the stuff y'all develop, and we don't mind one bit to help you all and whatever you develop and make it work. That's what's needed. We have sites set up. We have 60 sites across the island. We want to slice off some bandwidth off each site. We got the power to do it. And I've already talked to our director about that. That's something that we're willing to do if it's needed. You can also volunteer with us. We don't just need technology staff, but people who provide situational awareness on the ground. Help us with equipment, deployment logistics, human resources and onboarding, supporting, travel and building, vendor management, donation management, translators, because I'm not quite where I need to be yet, and I spent a week on the road in Zone 11, which is like Humacao, Yabucoa, and all that, and not as many people down there speak English as they do in San Juan, but I managed. But having some people who want to help out with us on that, on translation, that's great. And field level support, local area expert. I mean, there's been times when we were trying to get into a community and the roadways were destroyed. Google Maps only goes so, even if you have them cached offline and paper maps, only go so far. Sometimes people who's local to the area and knows those areas, get the Jeep, let's go. So anybody who can provide us support with that also, and the technical folks also. That's our information. Anything ever happens, that's our activation line that you call. It's pretty much staffed 24/7. Or you can also email ops@itdrc.org. And that's my presentation. That being said, I'm fairly interactive. And is there any questions about any of the things that I spoke about? Or anything that I may not have covered that you think I may have an idea about that?
Yes. Oh, yes. Thank you.
Yes, this is my voice.
What experience did you have in Puerto Rico or in any other areas that you've worked with amateur radio or that kind of technologies that are old school and probably lying around in the closet of some people not using it? So how that can help in the efforts of connecting and communicating people?
It absolutely can, and the ITDRC, they do have staff who are much more knowledgeable than me when it comes to amateur radio. We do have a lot of amateur radio equipment and licensed equipment also. I'm glad you asked that. But that's not my area of expertise, so I really didn't talk about it too much. But yes, no, that's absolutely usable, especially people who have their ham license. That has been used, as a matter of fact, over in the Echoes, the ONMDs, their radio network was pretty much raw. Both the towers that they had actually with their antennas, and there was a power grid that drive a lot of their equipment. We do keep radio equipment in our warehouse, and that is available for deployment also. But we do coordinate with a lot of Rico who do that on that. Yeah, we can work with them, and we even install computers and locations and things like that. Like I'm not an expert on that, but we do have some staff who's very, very, very adept in radio communications. That's not exactly what we use that.
Also, you talked about volunteering and helping with the ITDRC, and I know there's the website and all that, but can you talk more about the process and how people are selected, or how easy it is or how hard it is, so people know how they can get into this? Because this time we were hit, and in the past, actually, that when Irma came, Puerto Rico was like the center of relief for the smaller islands.
Right.
So I hope that we don't have to live through that again. But if it does happen again, how do we get more involved with the ITDRC?
Okay, so I was going to cover that once I was finally concluded, but no, that's fine. I can address that now also. Things have changed a little bit. One thing I was going to say is anybody who is interested in that, I'll stick around. We can talk about that also, because I don't want to hold everyone hostage. But one of the things that has changed is there's these independent study courses that FEMA has. Okay, and we get resources and some funding from FEMA, and they do want a lot of our volunteers to complete those independent study courses. There's 4 main ones. They're not hard. Before I even got involved in the ITDRC, I already had them completed because I've worked in emergency management before. So that's one of the big steps, is knocking out those independent study courses. Now, if something happened again, how close are we going to look at that? Depending on what roles you're fulfilling, I guess it would matter. But it's something that you definitely want to do, because it makes understanding what's happening a lot easier, because they have their own, FEMA has their own terminology, and when a disaster happens, they want everybody speaking the same language. They don't want to talk Spanish and English, but they all have their own, what they call it the NIMS, National Incident Management System. That way, like you may have a police department who has a code for some sort of function, and an ambulance service means that means something totally different. So that familiarizes the volunteers with that a little bit, and makes them understand the process and how the resources and logistics work and what we can provide. That's one thing that I would definitely suggest, and I can go into a lot more detail about that. If people were interested, and then just speaking to one like that, I'm not going to hold them hostage on that. But talk to me, and you can also, we have a forum on the website where you can give us your contact information, tell us about your skill sets and things like that, and we can go through that and decide, where best to be needed, because like I said, you don't have to be technically skilled at all. Is that it?
We'll talk more later.
Okay.
And finally, let some other people ask more questions. What experience do you have, if any, or have you seen the use of common off-the-shelf technologies? Like we were talking earlier, like taking a Wi-Fi router and using OpenWRT or something like that to get things going, because this is great, you know, all these sat links and VSAT and whatever technologies, but after a disaster, probably you won't have that at hand. So how this off-the-shelf technologies can maybe use, or have you seen how they've been used before?
I've not actually seen them in use before. I mean, we have been, you know, extremely, I don't want to necessarily say lucky, but we're very thankful for the relationships that we have with vendors to be able to have that gear. Now, the iniquity gear is pretty accessible, you know, for everybody these days. It's gotten a lot more inexpensive. But as for, you know, consumer grade routers running, you know, aftermarket firmware like ITDRC, OpenWRT, I have not personally seen it being deployed. Okay, I could see how it could be. I could see how that could be used, but I have not personally seen that in the field.
Anybody else have any questions? Don't be shy.
I don't need the mic, trust me. I'm the disaster response unit, I just yell from my eyes point. To the earlier question, and I apologize if you covered this, I've read it late. Do you have, if someone said to you, it's going to happen all over again, and we only have one technology choice, all right? And you've only got about $5 in everybody's pocket. Do you have something that for you, in your experience, you would say, build towards this, move towards this, in that kind of environment?
Well, when you're dealing with limited budget, as you were saying, I think that's a very, very difficult question to answer. You know, again, it's like I was saying, you know, we're very thankful for the relationships that we have and the equipment that we are able to use. So it would be very difficult for me.
Well, add on to that, right, in light of what's happening this week and this weekend. If we know you're going to be there at some point, right, and I think there's a high confidence that you guys will, you know, find a way to get at least close. Is there something that should, you know, we should be developing or thinking about that's going to be able to be listening when you start talking, or talk when you start listening?
Okay, so yeah, now that's something I can't expand on. It's like I was saying, you know, I don't know if you were here when I had a map of all the sites that we had across the island. Don't necessarily focus on super, super long range, because if we're going to be here, and you know, you definitely want to be, at minimum, if anything happens between now and then the hurricane season, I'll be here. I live here right now, so at least you'll have me. And we are, any of the gear that we had, the VSAC gear, that's no longer in use. We're actually now keeping and stockpiling down here. The logistics of sending it back is, we might as well keep it down here just in case. So knowing that we can have, you know, a lot of, you know, nodes across the island, if you use as gateways, don't necessarily focus on shooting all the way across the island. It doesn't have to necessarily be that long range. It's kind of like me and Javier was talking about earlier. It doesn't have to be a true mesh. It could be a fractured mesh network, a bunch of meshes connected to a gateway. And then all that data can be exchanged.
And that gateway is or should be.
I tend to favor VSAT, and the reason I favor that is if I can see the sky and I have power, it works. It's not dependent on any of the terrestrial lines, and that's not the concern. And so that's kind of going into what you're talking about also. If it's going to happen again, should you focus on point-to-point, you know, different technologies? It might be different if those fibers get destroyed. That's going in the same one. That's a simple point of failure. You're talking VSAT initially because you're not going to do anything else. You're not. It's just not going to happen. You can do that all you want. That won't be the island. So, you know, it's difficult to say. You know, what's going to happen?
I can add to that too, because you mentioned VSAT. I think to what Derek is mentioning about fractured meshes or taking advantage of any other backhaul that you know. That backhaul could also be a business with that didn't lose connectivity and has some sort of Wi-Fi hotspot. You can go in and help, and if you have any technical skill, you can help to upgrade that sort of wireless distribution, and that's where the area of a mesh network. I mean, if you have the OpenWRT or any sort of equipment that perhaps is not long range, but can create some sort of community or small network, that could help. Anything that adds on to the connectivity. Also, through the Puerto Rico Science Trust, Extreme Networks, and with the collaboration of another company called Bay Networks, donated a healthy amount of high-density Wi-Fi access points to the University of Puerto Rico. So, and during the hurricane, the University of Puerto Rico didn't lose connectivity. They have backhaul. They just didn't have maybe enough wireless infrastructure to create community Wi-Fi access points. So now with this equipment, they could do it as well. So there are going to be different organizations like ITDRC. You could have University of Puerto Rico. You have other areas that may have these backhauls. I guess the point to the community could be maybe a good project would be list these backhauls that exist and we know are working, so that the rest of the community developers could and network engineers could use them and build around them.
Correct. So some of you don't, maybe most of you don't, ITDRC, IBM. When I was in the quake of 1989, I've been extremely unlucky, so you probably want to sort of stay away. But in the quake of 89, we had a neighborhood phone that could dial long distance and a neighborhood phone that could dial local. So people were lined up depending on who they would call. And to the statement he was just making, the more we can look for in a disaster, I'm sure everybody here is familiar with the idea, not the phrase, you start where you stand, right? There's plenty of mess here afterwards, right? During and afterwards. You didn't have to look far to find the problem you could work on. And, so things like that practical list, because the technical people in this room can, say, oh, look, I've got a router. I was about to throw it out last month, but I didn't. Now I have that. What is it I need? Where are battery sources? And I think large organizations like yours, like mine, right? What can we offer sort of superstructure infrastructure that says we'll get your message all the way out. If you can get it to us, and here's how to get it to us. DSAT, who doesn't love? I've not figured out how to justify carrying a couple of those.
Well, they make some really small units, but they're really, really, really expensive.
Yeah.
They have some that auto align and you can use on moving vehicles. If you have $20,000.
Yeah, exactly.
It can, obviously the mounted variance is the most economically feasible and gets the most bang for your buck, really, because you get better service with it. I mean, obviously they move on the fly, they move on ships and everything else. Matter of fact, one of the ships that was housing a lot of the FEMA responders, the TS Kennedy, we didn't have anywhere we could mount on the shore, so we mounted it on top of the ship. We had to go and adjust it frequently. But, yes, we can help with something like that. Like Javier was talking about, we knew some of that before. We got started talking when we were in the back room. We got down here, we've never operated a Puerto Rico before. So it was all new to us. Now having a list like that, like you're talking about, a place that's likely to still have connectivity, that would have been really, really great to have before. And if it's needed again, yes, that's something we would definitely like and anyone here can talk about. Because, and I believe what you were alluding to is, could, for instance, if, say, UPR, one of their sites, and they want to work, could we go there, throw a second antenna up on top of there, and beam it all over on the mountainside, so all the different communities out there? Yeah, we could do that. And that's something we'd be interested in doing if it's going to ultimately help the people. Obviously, we have to triage, where we're going to help first and everything. But no, that is something that we can help with.
I think one of the everybody here is driving towards some level of acting on everything is just trying to get information to somewhere central that.
And then it can be offline.
Talking really like, yeah, you know, I mean, you can't triage, you can't talk to them, and,
Right.
you know, everybody wants to, you know, survive the big game, wants to play in the big game, nobody wants to practice. That's why I'm down here, so I'm excited by you guys, because we're all sort of saying, you know, let's practice this, let's figure out how to connect before we're doing it, you know, in the middle of a massive storm.
Right, yeah, that's what I'm saying, you're going to punch in the mouth.
Yeah.
You know, you want to have a game plan ahead of time, because trying to come up with one on the fly when everything's already tested.
You used to have a phrase that you have the rest of your life to figure it out.
Yeah. Well, and
Like words on.
so what you were saying, I mean, I kind of touched on that a little bit in some of the slides. You're saying, you know, you had that some communication to triage. What kind of data are you trying to move? You know, I talked about some of the heavy hitting stuff like geospatial data and diagnostic imagery. To get to that point, you got to know where that happens. And, you know, what Jose was talking about, you know, with amateur radio and some of that, that is a way a lot of the information gets back, you know, to a central point, say, well, this community said this community said that. You're not going to immediately after disaster give them an enterprise grade back. It doesn't happen like that. You have to know what community needs it and assess what needs it the most, you know, can we even act? Use of a network that you might say would be substandard that we would look at, you know, the regional network. That's junk. But if it's junk and it's reliable and it gets you the data that you need, that's fine. That's fine. That's what I'm saying. You have some sort of data that's not very large. You get a lot of bang for your buck out of that. You know, like I said, people points. That's not a lot of data. That's weapon points. I mean, that's nothing. But that makes a huge difference, you know, in some people's lives. And then, just like you're saying, also, you can almost get the data that we need through an SSH session. You could literally do that command line. I mean, a lot of government agencies, they use the old IBM 3270 terminals.
Oh, fine piece of equipment.
Hey,
Just because it's older than you, that's.
I'll work on it. And even without the actual physical terminals, a lot of them run emulators on the actual EPOM. Because a lot of government databases are access to 3270. But even that, think about this, very simple text, no graphical user interface. You can deliver a lot of information like that. A lot of police dispatch systems actually do like that. So, yeah, you know, it doesn't have to have a ton of throughput. I mean, something like that can help.
It's a great point to be my own commercial. Friday night, we're talking about design thinking. That's exactly the kind of thing when you're building these systems. I've seen some of the development work that comes out of people in here. It's great stuff. And it's skinny as it is, right? It's back for the kinds of things we're talking about. Text interface, low speed, low grade, but, you know, and I will, by the way, because I'm that kind of person, I will get choked up when I think of the things I've seen and what's come through. But I've seen, you know, moms who know their kids all right, you know, you have no idea what that can mean. That's a text. You know, that's a text. And you know, you can do that in 40 characters. I mean, you know, it makes Twitter look fat. I think we can think that way. And we can figure out, you know, just, you know, how to solve those problems. The fractured mesh statement, I thought was great. You know, my town, if everybody just worried about their town, every town would be okay. You know, we figure out how to connect together. So if you want something to motivate you, when you're tired on Saturday night, the same thing, you're going to come up with the idea, you know, some moms wouldn't know their kids okay. You can code for a few more hours. You know, but when we talk about design thinking, we're trying to fit some of that in a short time we have. Please don't ask about this. this was, what I caught of this was great, and a lot of it was up here for me, which is good. You can't all the experts and everything. However, you can be the island.
Well, I'm not, that's the thing, I do, I live here now.
I'll be happy to write it.
Well, I'm supposed to go get my license today. It'll be official, you know, I have a border review driver's license.
We have that system.
I have time to do it yet, but I knew I was gonna be here for a while when I would get a lot of site contacts, and I was like, okay, what's the best amount of contact, you know? SMS was great. That does it would eventually go through. Voice was always spotty, but if you could, get with me on WhatsApp, and I'm like, I don't like WhatsApp. Eventually I installed it. Like, oh, you're getting closer. You're getting closer to actually being fully integrated with the island. I would have to read WhatsApp before, but apparently it's very, very common. So I now have it, but and I'm going to copyright that, Javier, fractured mesh. The IBM guy says he loves it. I'm going ahead. I'm going to get with US Patent and Trademark Office. Next one he says it will be value royalty.
Just build. Okay.
I would do that. But and like you were talking about with the very, very simple, you know, text-based, I mean, like that entry in 3270 terminal. Some things that I've seen and I've worked on in the past. I know a lot of people here who are used to newer technology, like, oh God, no, I don't want to deal with that. But there is ways you can use modern applications with 3270 terminals and things like that. Like, for instance, we had where you could like take down a bunch of information, for instance, into an Excel spreadsheet, and then we have a macro that wrote DB that would actually open the 3270 emulator and do the XY coordinates. It's just, I mean, faster than you could ever imagine. Build that and transmit that data out. But you are actually taking the information down on a graphical user interface or whatever. You can build it.
That's the forehand first transmitter.
Yep. Yep. So there's a lot of different ways you can work around, you know, having limited capacity. I think we're still going there though.
Anybody else have any questions? For there? Okay, we have one here.
Hi, my name is Luis. Excuse me for broken English.
It's okay because
I used to manage this stage, an off station here in Puerto Rico back in, let's say, 2009. The other board was located in Macau. I know these, you guys were relying on consider any other piece of platforms, let's say iDirect?
we have access to other vendors at this point, using that just through a lot of equipment. We've worked with Vistat in the past, and some others. I'm more familiar on the Usenet side because that's the majority of what we use down here. But no, we're vendor agnostic. I mean, we'll use others. Just so happens for Puerto Rico, that's what was mainly used. And one of the reasons I suspect for that is when they got EchoStar in 1990, that wasn't very long ago. And when they got up, I mean, that it was put into orbit, I believe, in late 2016. It was actually put into orbit, and they were getting ready to put it to full production and have a footprint for this island a little bit after Maria. So it's like, I just want to go ahead and do it. That's my understanding. So that's why that ended up being the name back all that was being used. And we were satisfied with it, don't get me wrong. Obviously, a lot of people who's looking, you know, at VSAT technology in the future. I know Tesla's moldy idea, from what I'm understanding about using much lower orbiting satellites. That's not reducing anything. But also, we're at the mercy of what we can access.
Any other questions?
Or critiques, whatever.
I was going to ask then, I guess, in tune with this question and the last piece, information you gave there. So, thoughts on low orbit satellite deployments that you're excited about, or you think that would be helpful at any?
I think it'd be great if they actually get those in place. Now, you know, we would use them. Don't get me wrong. How feasible is it going to be for a large company to actually get these satellites in place? I'm not sure. I mean, obviously SpaceX has just been going at it when it comes to, you know, commercial, you know, space exploration and deployment of satellites. I believe they just deployed a satellite for Iridium, not a super one of it. I mean, it would be hard for me to say because I certainly don't put them up in the sky. I just use them.
Fair enough. Officially, I guess.
All right, so I guess we're good then.
Yeah. Of course, we can continue the conversation offline, and we'll be here talking. But just for the people on the live stream, thank you all for joining, both here present and remotely online. Thank you so much, Derek, and the ITDRC for this wonderful presentation. And don't forget, we have another event, Link, PR, shout out to Link. We'll have an event tomorrow on blockchain and decentralized applications here in Engine 4 at, help me out, say what time? 5:30. Then Thursday, Microsoft will have another one on Intelligent Edge serverless architecture starting at 8 a.m. It's going to be an all-day workshop. And Friday, we have Althea Mesh, a company at the intersection of blockchain and mesh networks, here at 8:30. And then Dr. Corey Baker from the University of Kentucky will be here at 1:30 p.m. talking about delay tolerant social networks. And IGM will grace us with their presence later at 6:30 for a design thinking workshop. And of course, the hackathon kickstarts at 5 p.m. Friday. Social, we have all this information at our website, and Obsidian Consortia has posted, PR Connects, and myself have posted all the links. So with that, I'll leave you. Have a good, very, very good night, and thank you so much.
And if any of y'all do want to speak to me about volunteering, then I'm going to be hanging out for a little bit, but I don't mind if you want to go home also.